Hello everyone, welcome to today's session on Python module and packages. Module and packages are two concepts that facilitates modular programming in Python. To understand modular programming, we will use this project structure. As you can see, I have a huge application to develop known as Python for All. What I have done is I have divided my Python for All application into smaller subsections or smaller modules like data scientist and HR. The advantages of modularizing my code is simplicity, maintainability, and reusability. Next, let's try to understand what a Python module is. As you can see, I have defined a .py file, and any file with a .py extension can be called as a Python module. Inside this .py file, I have a string variable message, an integer variable, then I defined a function, and then I am calling a function at the end of my module. Now don't worry about this syntax of defining function and calling a function. In my future video, I am going to cover how to define a function in Python. So whenever someone asks you what a Python module is, in simple words, it's just a .py file with some variables, functions, and classes. Next, how to understand Python package. So any folder which contains multiple .py files or multiple modules is known as a package. If you have huge applications which have subsections inside it and those subsections consider some modules or .py files, then data scientist and HR folder here will be called as subpackages. Now you can see there is a weird file we have in these folders which is __init__.py. This two underscores in Python has a special name and it's known as dunder. Dunder variables or names have a special meaning for Python interpreter. Prior to Python 3.3 versions, you must have this _init file in your folder to make your folder a Python package. But in the latest versions of Python, after Python 3.3, it is not a necessity. You can skip creating this .py file and still your folder will be considered as a Python package. Next, let's try to understand how Python imports work. First thing, you have to use a keyword import to import a particular module in your Python environment or in your Python namespace. Here I have created a local module known as module_example, and when I want to import it, I will use the import keyword and then I will give my module name. If you want to see how module_example, this is how it looks. As I said earlier, it has a string variable, an integer variable, and a simple function, and I'm calling this function at the end of my module. Let's see what happens when I import this module. When I import my module, you can see I'm getting a message, this is module example. So the first time when Python loads the module in your Python environment, this is going to execute these statements. And as you can see, I'm calling this function. That's why I'm getting the message, this is module example. Now once the module is in your Python environment, you can access all the variables or functions present inside that module by using the module name and the dot notation. So I have used my module name, which is module_example. Now I will use dot notation and I will press tab on my keyboard. As soon as I press tab, you can see I'm getting example, message, and print message which are present inside my module. If I select example and simply execute this cell, I'm getting 1 as the output. In the same way, if I want to call a particular function, let's say I have a print message function. If I want to call this function, I can simply get access to that function by using the dot notation and I will execute it. I'm getting an error now because this function accepts an argument. So I will pass a hello argument when I execute this. You can see I'm getting the message. So by using import keyword, you can import the module, and then by using the dot notation, you can get access to its variables, classes, and functions. Alright, so we know how to import the module now, but how this import works. So whenever you use this keyword, what Python does, it will start looking for this particular module first in the sys.modules space. If it doesn't find this particular module present in sys.module, the next place it will go and look for the built-in module section. The built-in module section is created when you actually install Python in your system. If it's not able to find this particular module in this section also, the third place it will go and look for this module is sys.path. This is the path where your third-party modules generally get installed. If the module is not present in any of these three paths, you will simply get an error message which says module not found. Just to show you, I will import a module which is not present in any of this path. If I execute this, you can see I'm getting an error message which says module not found. Alright, next we want to know how to reload a module. Let's say I make some changes to my module and I want to reload it. Okay, you cannot reload module by simply executing this cell block again. As you can see, we are not getting anything new here. Even we are not getting the print message that we are getting earlier. This happens because Python only loads your module once, the first time when you execute this. After that, just for efficiency reason, it never reloads your module. So if you want to reload your module, you have to use a module which says import lib, and inside this import lib module you have a method reload. To this method you can pass your module name, and when I execute this, you can see I'm again getting the message which I get at the first time when I imported this module. So the first way is to use the import lib module reload method. There is one more way to reload your module. So you have to go to this kernel option and you have to restart your kernel. When you restart your kernel, it actually flush out all the environment and it is giving you a clean slate, right? So once you restart your kernel and if you execute this, you are again getting like we have first time when we executed our module. Alright, next is styling of import statements. So as per Python community guidelines or Puppet standards, you should always have your import statement at the top of your file. The second style is each group of imports should be separated by a blank line. So as you can see, I have 3 groups here and I'm separating them by a blank line. The third style is imports should be divided according to what is being imported. Now there are 3 kind of import statements I have here. First are the standard library imports. So these are the default modules which I have in Python. The second import group is of the third-party imports. So I have installed Flask and other modules, by using pip install command. So that they should come second in order. And the last import that I'm going to do is for the local modules that I develop. So as you know, I have developed this module. This should be last in my order. So this is on how to give styling to your import statement. Next, what are the different ways to import a Python module? So we have already seen how we can import a module by using the import keyword and then giving the module name. Here I am importing the math module. This will import all the functions which are present inside math module. So let's say I want to calculate the factorial of a number. So I know the factorial function resides inside the math module. So I will do import math. Then I will use the module name, and by using dot notation I will access this factorial function and I will pass the number for which I want to calculate the factorial. If I execute this, I am getting 120 as the answer. In the same way, we have a very special module OS which gives us operating system functionality. If I want to know my current working directory, I can use this function from OS module to get the current working directory. So as you can see, this is the current working directory for me. Next style of import is by using the from keyword, right? So sometimes it happens that I don't want to import all the functions from math module. In advance, I know that I am just gonna need the factorial function. So what you can do is you can use a from keyword. After from keyword, you have to mention your module name, and then you can use your import keyword and mention the function name. What it does is only gonna bring one function imported from the math module. Rest of the functions will not be imported. It is very efficient when in advance you know that you're not going to use all the functions in a particular module. Also, one more difference is you don't have to give the module name or use the dot notation like we are doing earlier. So earlier we are doing math.factorial, and now I'm just giving the function name and passing the number for which I want to calculate the factorial. So 2 advantages. First, it is much more efficient in comparison to importing all the function. Second, you don't have to give your module name or use the dot notation. If I execute this, I will get the factorial of number 3, which is 6. Next, let's say I want to calculate square root also. So I know that inside math module I have a square root function. If I execute this, I'm getting an error that square root function is not defined. This happens because I just imported a single function from my math module, which is factorial. So what happens when I use 2 functions from my math module, right? So you don't have to import all the functions. What you can do is you can separate the function name with a comma, and in this statement I am saying that I just want to bring 2 functions from my math module. If I execute this, import has been successful, and if I execute this again, I'm going to get the square root of 9, which is 3.0. The next style is again by using the from keyword. It says from math import star. When you do this, what it's gonna do is gonna import all the functions which are present in math module, right? And of course, you don't have to give the module name or the dot notation. You can directly use the function name and pass arguments to it. Now here in bracket it's written generally discourage, because what happens when you do star, it's going to bring all the function, and one dangerous thing it will do is it's going to overwrite all the local functions which you have with this particular name or with any name which is present in your math module. So that's why this is generally discouraged. If you have a huge application, do not use this syntax to import function. Always goes for from math import or the import math syntax. The last style is very useful, which is known as alias. So what happens is sometimes module names are very big, right? And we generally follow this syntax to import the modules. So you don't have to write pandas again and again. What you can do is you can use as keyword to create an alias. So for pandas, I have created an alias of 2 characters, which is P and D. So whenever I want to use pandas functions or variables, I can simply use PD instead of pandas, and it will work like it used to work earlier, right? I have to pass some variables to it, so I'm not going to import this, but the alias is very useful when you have your module names much bigger and you can make them shorter by using as keyword. So that's all about how to import a module in Python. Next, let's see how we can import packages. So we have seen earlier that data scientist is a package, and then we have a huge application Python for all. Inside it we have some packages like sub packages like data scientist and HR. To import a particular module from a package, this is the syntax. So you have to give from keyword, then the package name, and then you can mention your Python for all name, right? So this is my .py file which is present inside Python for all. If I execute this, you can see the Py for all is giving me a message that this is a module example. Now if I want to execute the functions or variables which are present inside this particular package or inside this particular module Py for all, I can again use the dot notation and the function name. Next we will see how to import the modules or function from a sub package. So again, inside package, if you have a sub package, it's very simple and straightforward. You have to give the package name first, then the sub package, then you will give import, and then your salary.py. So if you want to see this in a project hierarchy, this is how it looks like. So I have my major application, which is Python for all. Inside that I have a data scientist sub package, and here I have my salary.py module. So I want to use this print hello, or I want to print this message. What I have to do is first I will write my package name, then the sub package, and then the module that I want to import from the sub package. Once I execute this, I can simply use salary and then the dot notation to access the print hello function. There is one other way to use the sub packages module. Instead of this, if you can directly give this syntax, right? So let's say I don't like the from import thing, so I can simply use my import keyword and I will give the absolute path to the module. So I have used package name, sub package name, and then the salary.py. If I execute this, and I can again execute this, so it will remain same. There is no change. Instead of this, actually you have to use this one, Python for all data scientist .salary.print hello. Now you can see this whole absolute path is huge, right? I don't want to write it again and again. So here, as I said, the alias thing will come in handy. So what you can do, you can use as keyword and you can give this name as PDS. I will execute again, and now if I want to access my print hello function, I can simply do pds.print hello, and you are getting the message as hello data scientist. Alright, so now we know how to import modules, and then we understand how to import the packages. The last thing for today is this dir function. Now whenever you want to know what functions exist inside a particular module, what you can do is you can pass the module name to our inbuilt dir function. Right? So I imported a package math, and now I want to know how many functions inside math exist. So what I will do, I will use this dir function and I will pass my module name to this dir function, and I will execute this. And as you can see, all the functions name which are present inside math module are coming here. You can see power functions and logarithmic function. So this dir function is sometimes very useful to know how many functions are present inside a math module. Alright guys, that's all for today. Thanks for watching. If you have any question, please feel free to put the questions in comment section. Happy learning and stay safe.